Today, humans live permanently off-planet. We maintain a massive, continuously occupied laboratory flying hundreds of miles above our heads. We also have heavy machinery operating daily on the surface of Mars, taking pictures and drilling into alien rock. Space exploration has become routine. But before 1957, humanity had never sent a single object into space. Scientists were experimenting with rockets, but the consensus was clear. The sky was a hard physical limit, and achieving stable orbit was widely considered impossible. Every satellite, rover, and space station we rely on today exists because that physical barrier was finally broken. At the time, the world was rigidly divided. The Soviet Union and its allies stood on one side of a tense global standoff. The United States stood on the other. The two superpowers were locked in a Cold War, resulting in a dangerous geopolitical deadlock. Building more nuclear weapons resulted in a stalemate. The rivalry shifted toward pure technological dominance, operating on the belief that whichever nation controlled the most advanced science would secure the future. Deep inside classified Soviet laboratories, engineers were handed a staggering directive: to demonstrate ultimate power by building a device that could escape Earth's gravity entirely. To stay in space, an object has to achieve orbit. This means it must travel at such an immense velocity, roughly 17,500 miles per hour, that as gravity pulls it down, the curve of the Earth falls away underneath it. It is continuously falling, but moving so fast it never hits the ground. Reaching this altitude became the ultimate strategic high ground. Controlling orbit meant looking down on a divided planet. The engineers designed Sputnik 1. It was a polished metal sphere that was surprisingly small, roughly the size of a standard beach ball. Extending from the polished casing were 4 long, swept-back trailing antennas. Inside, the payload was strictly limited. It carried no cameras, no scientific sensors, and 0 life support. It held only a basic radio transmitter and a silver-zinc battery. Curious, it was a remarkably simple, almost harmless-looking object, yet it was engineered to execute an incredibly aggressive geopolitical maneuver. On October 4, 1957, a modified ballistic missile stood on the launch pad deep in the remote deserts of Kazakhstan. The operation was entirely classified. There were no press briefings and no cameras broadcasting to a global audience, just a handful of tense engineers waiting in the dark. The engines ignited, violently pushing thrust against the launch pad, and the rocket tore a path into the night sky, carrying the payload with it. Minutes later, high above the atmosphere, the payload separated. The satellite achieved the necessary velocity and entered a stable orbit. Humanity's first physical breach of the cosmos happened in total silence, a tightly kept secret that succeeded before the rest of the world had any idea. The true brilliance of the mission lay in its ability to prove its own success. The satellite automatically broadcast a continuous, undeniable audio pulse, a simple beep, beep, beep. That frequency washed over the entire planet. Anyone with a shortwave radio could tune in. Government officials, military radars, and amateur civilians all intercepted the sound. The global reaction was deeply split. Many scientists were struck with awe at the engineering milestone, while millions of civilians felt a sudden existential dread. In the United States, that dread turned to panic. The steady radio signal was hard proof that a Soviet device was successfully flying over American territory every 96 minutes, and the military had absolutely no way to shoot it down. A repetitive radio pulse took the abstract mystery at space and turned it into an immediate, undeniable physical reality. The psychological shock of that beep mobilized the United States. It triggered a massive, immediate influx of government funding, creating new aerospace agencies and officially starting the space race. This reactionary frenzy of innovation compounded year after year, directly paving the way for the Apollo missions and placing human footprints on the surface of the moon. Sputnik 1 itself had a remarkably short lifespan. Its batteries died after 3 weeks, and orbital decay dragged it back into Earth's atmosphere, where it burned up just months after launch. But its physical survival was irrelevant. That single metal sphere and its short broadcast proved the sky was navigable, turning an impossible physical limit into the ongoing era of human exploration.